Hello, welcome to the next part of the 8086 microprocessor, where in the last class we have discussed about the key features of 8086 processor. Now today our topic is about the pin configuration of 8086. There are 40 pins present in 8086, 20 in the left side and 20 in the right side, as you see in the picture. So what are the pins and what are their usage and what are their specification? So let's get started. Myself Anubhab Sarkar, EEE Department SBIST. So let's get started into the video. In first, address and data signals. What are the address and data signals? You should look AD15 to AD0. There is 16 pins are present for the address and data bus. This bus consists of 16 lines that are multiplexed, meaning they serve dual purposes. So what are their functions? Function is this: during the first clock cycle, these lines carry the address of the memory location being accessed. During subsequent cycles, that is T2, T3, T4, they carry the actual data being read from or written to that address. And what is the importance of this address data bus? This multiplexing reduces the number of physical lines needed, optimizing the design and cost of the microprocessor. And now shift to the address status bar. Address status bar starts from A19 to A6. This bus consists of multiplex lines that serve both address and status function. What is the function? During T1, the upper 4 bits of the address are transmitted. During other cycles, these lines carry status information. S6 always 0, indicating a fixed status. S5, which indicates the status of the interrupt enable flag, which is crucial for managing interrupts. S4 and S3, that indicates which segment register is being used. And 00, 01, 10, 11 are ES, SS, CS and DS that we all know extra stack code data. Now the last point is bus high enable status signal, that is BHE. This is another multiplex signal that plays a critical role in data transmission. Function is during T1 cycle it indicates whether the upper byte of the data bus is being utilized, and during other cycles it carries status information which can provide additional context about the operation being performed. Is it clear? Now next to the next slide. The control signals. In control signals, the main control signal in 8086 microprocessor include RD, that is read, write, memory input output, address latch enable, data enable and data transmitter receiver. Clear? So what are these? In read, you all know read means an active low signal indicates that the microprocessor is performing a read operation. Function is when RD is activated, the microprocessor requests data from memory or an input-output device. This signal ensures that the database is prepared to receive data. Next is write, that is WR. An active low signal indicates that the microprocessor is performing a write operation. When write is activated, WR is activated, the microprocessor sends data to memory or an input-output device. Next one is M/IO, that is memory input output, which describes the signal differentiate between memory and input output operations. When this pin is high, the operation is a memory operation, and when this pin is low, the operation is directed towards the input output device. Next one is ALE, that is address latch enable, which describes the signal indicates when the address is valid on the multiplex address data bus. Next one is data enable, DEN. This signal activates external data buffers to enable data transfer. Function is when DEN is activated, it allows data to flow between the microprocessor and external device. This ensures that the data bus is ready for either reading or writing operation. Last one is DT/R, that is data transmit receive. When DT/R is high, it indicates that data is being transmitted from the CPU to external device. When it is low, it indicates that the data is being received from external device to the CPU. Clear? Now moves from controls. to the additional 8086 signals. One more pin is remaining is the ready pin. Ready means the ready signal is an input signal used to synchronize the CPU with slower memory or input output device. When ready is low, CPU enters wait states, pausing its operation until ready goes high. This ensures that the CPU does not attempt to read or write data before the slower device is ready to respond. Now moving to the additional 8086 signals, which includes interrupt request. First one is the interrupt request. Interrupt request means the CPU acknowledges the interrupt request if the interrupt flag is set. This allows external device to interrupt the CPU to signal that they require attention, enabling responsive multitasking. Next one is INTA, that is interrupt acknowledge. This is an output signal, remember, indicating that the CPU has acknowledged an interrupt request. When the CPU asserts inter, it informs the requesting device that it is ready to process the interrupt. Next one is NMI, that is non-maskable interrupt. This signal is used for critical events that requires immediate attention, such as hardware failures. The CPU will respond to an NMI regardless of the current state of the interrupt flag, ensuring that urgent issues are addressed promptly. Clear? Now, the next is bus attribution signal. Bus attribution signal. In the first part is hold request pin, which describes an input signal that requests control of the system bus typically used by a direct memory access controller, that is DMA controller. Next one is HLDA, hold acknowledge, an output signal indicating that the CPU has granted control over the bus to an external device. When HLDA is this pin is asserted, it confirms the requesting device that it can proceed with its operation on the bus. Next one is clock pin, that is CLK. Typically generated by an external clock generator, it synchronizes all operation within the microprocessor, ensuring that data is processed in a timely manner, as we all know. Next one is the reset pin. This is a very common pin which is present when it is activated. It clears the instruction queue, sets the code segment register to the prepare and the CPU to start execution, start instruction from a known state. And what are the status signal now? Status signal means S0, S1, S2 bus cycle status. Means they are decoded by external circuitry to generate appropriate control signal for memory and input-output device, facilitating the correct operation of data transfer. Now moving to the next part, the QE status. This signal provides information about the status of the internal instruction queue. They are used for debugging and advanced system control, indicating whether the queue is empty or contains instruction. And what are the bus cycle status? Bus cycle status, this signal indicates the type of bus cycle being performed, memory read, memory write or input output operation. They are decoded by external circuitry to generate appropriate control signal for memory and input output device, facilitating the correct operation of data transfer. And the last one is the power and the ground pin. As we all know, power and ground pin, that is the positive and negative, is required for everything, every electronic component to power on the device. So power supply for the CPU is positive 5V and the ground for the ground reference of the CPU. So up to this, it's clear all the pin configuration of 8086 microprocessor. Thank you for watching.